We're going to solve a polynomial inequality. We will graph the solution set on a number line, and then we're going to express that solution set in interval notation. So here is the polynomial inequality, which I'm circling in purple, and we know that it is an inequality because it's not an equal sign, it is a less than or equal to sign. And when you have these, there's two things you have to do. The first thing, you need to make sure that you have a 0 on one side. And that's already here for us. Okay, here's my 0 on one side. I put a little smiley face in there. The second thing you need to make sure of is that it is factored. And it is factored here. Okay, you see that these are two factors. If it was not factored, it would look like this. Let me FOIL this out in my head. Okay, if it's not factored, it would look like this. So, and you can tell that this is a polynomial, unfactored polynomial. So the idea that this problem is factored is great. We don't even really need to look at this. So when we go to find the graph on a number line of the solution set, we're going to use boundary points. So let me graph this polynomial so you can see what it looks like if I was going to graph just the polynomial function. So I'm going to come over here, and here's what the graph is going to look like. All right, you could do this on a graphing calculator or a Desmos. All right, this is a parabola. It's a big smiley face, and it's going to look like this. And you could see what the question is asking, this inequality. It's saying, when is this thing less than or equal to 0? So the good part in this question is going to be this part down here in the pink. Everything in the pink is less than or equal to 0. All right, and the other parts are not less than or equal to 0, they're greater than or equal to 0. So I'll put those in yellow. Okay, this part is greater than or equal to 0. So the pink part is less than or equal to 0. So it depends on what they're asking us, whether they're asking about less than or equal to or greater than or equal to. All right, now I have boundary points. The boundary points are going to be all of the x-intercepts. So if I'm not looking at this graph, let's say I didn't have the graph, my boundary points are going to be at 1 and -4. Okay, I get 1 from this and -4 from this. So I know those are my boundary points. Now when I go to graph the solution set, which is, it's the part in pink, when I go to graph that on a number line, here's my number line. I need to find my boundary points of -4 and 1. And I am telling you this, that everything in this interval will all give you the same result. Every number in this interval, when you plug it in, will either be less than 0 or will be greater than 0. Every single one. Every number in this interval, which I'm going to circle in, let's do green, is going to be the same. It's either going to be less than 0 or greater than 0. And then the same thing over here, I'll make it in brown. Every number in that, so I have 3 possible intervals. And to find out if they're part of my solution, I just need to test a point in every interval. So I need 3 different test points here. I need 1 test point back here, I need 1 test point in here, and I need 1 test point here. You can pick any number in those intervals you want. Over here on the left, I'm going to pick -6. In the middle, I'm going to pick 0, because that's usually the easiest to plug in. And then on the right, anything past 1, I'll pick 2. All right, now I need to see if these test points work. Depending on what the test points tell me, I will be able to find my solution. So let's plug in a -6. I grab my original inequality, do a little computer magic here. I'm going to plug in that -6. All right, we don't need a smiley face. So instead of x, I'm going to plug in a -6. I'll do it here and I'll do it here. And let's see if I get a true statement or a false statement. -6 minus 1 is -7 times -6 plus 4 is -2. And that gives me a positive 14. Is 14 less than or equal to 0? And the answer is no. So everything in this interval right here is not part of my solution. I'm going to put a no. All right, let's check our other two test points. So save some space. I'll plug in a 0 next. All right, plug in a 0. 0 right here and a 0 right here. 0 minus 1, negative 1, times 0 plus 4 is 4. Negative 1 times 4 is negative 4. Is that less than or equal to 0? And the answer is yes. So everything in this interval right here is part of my solution. All right, and now oftentimes these intervals will alternate, but not always. So let's check the last interval. All right, our test point over here is a 2. I'm going to plug in a 2. 2 minus 1 is 1. 2 plus 4 is 6. 1 times 6 is 6. Is 6 less than or equal to 0? And the answer is no. So everything in this interval is a no. So looking on the number line, what is my solution set? My solution set is this interval right here in the middle. It's everything from negative 4 to 1. Right? Nothing out here will work. Nothing over here will work. So the last thing I need to figure out is what to put on the negative 4 and what to put on the 1. Is it a parenthesis or a bracket? So I look up here. It's less than or equal to. Okay, this line tells me I need brackets. So I'm going to have a bracket here at negative 4 and a bracket here at 1. All right. If you plugged in a negative 4, you would get into the original. You would get 0. Is 0 less than or equal to 0? Yes. So those boundary points are included. So this is what my graph is going to look like. And then I need to put in an interval notation, and I'll do that down here, interval notation. And if your graph is good, you can just pretty much drop it down. I have one interval that is included in my solution. It goes from negative 4 to 1. And I get a bracket and a bracket. So there we have it. Polynomial inequalities. You're going to set it equal to 0. You're going to get 0 on one side. You're going to factor the polynomial. You're going to find your boundary points, and then you're going to test a point in between every interval.